Okay, so you want to print one of my really neat 3D printed rockets, fully integrated structural designs. You need to do some funny work with your slicer because your default settings are not going to work. So let me show you how to make this work. Only two slicers I'm aware of will work with these models. That's Simplify 3D and Prusa Slicer. If you use anything besides those two, I don't know how to make them work. I've been trying. If you can figure out how to make them work, please let me know. So here we are ready to slice a fin can. Now the magic of these models is they are completely in vase mode. There's no top layers, there's no bottom layers, there's no second perimeter, there's no retraction, there's no stopping. It's one continuous, constant, non-stop extrusion from all the way at the bottom, all the way to the top, non-stop, without fail. To get the slicer to do that is going to be tricky because there's a lot of weird things in this model. Cuts and slices that go through the model that have almost zero dimension, 0.01 millimeters. And if you don't slice it properly, you lose the structural integrity. Because remember, this is single wall vase mode, but it's a complex shape. How do you do that? You do that by creating judicious cuts and slices here and there that allow you to create a complex shape in vase mode. So the first thing we're going to do, under print settings, we need to disable all of the intelligence in Prusa Slicer. It's going to try to be smart, and we need it to not be smart, because when it's smart, it's going to do things that break the model. I have all the smarts engineered into the design, so you got to disable the smarts because they'll conflict. So set your layer height 0.2, 0.2, and you're also going to set your min-max to 0.2. Your perimeters to 1, select spiral vase mode. Down here, solid layers, top 0, bottom 0. I don't think you need to mess with any of this unless you've already changed that. Okay, infill doesn't matter. If you are printing on a Prusa, you probably have a PEI print surface. You are going to want to have a brim. Only two 0.4 millimeter perimeters, so a 0.8 millimeter thick layer is all that is touching the bed. That's not a problem most of the time because it's in vase mode. Vase mode is very, very forgiving of things like that. I've actually had a model break free from the bed and it just sat there on the bed under its own mass and it just kept printing. And it finished. Of course, I saw a little string and I had to touch it. I had to touch it, didn't I? But it finished. Give it credit. Um, add a brim, have like a 0.1 separation to the part if you're worried about too much squish. But yeah, add a brim. They're pretty easy to peel off. Now, under advanced, these three up here, default extrusion width, perimeters, and external perimeters. I'm not sure which of them is critical, so I just set all three to 0.4 millimeter. Actually type in 0.4 millimeter. And then the most critical setting of all, if your model has a whole bunch of holes in it or missing bits in it, this is why. Slice gap closing radius has to be set to 0. Because otherwise, you'll notice there's a number in here. A lot of the engineered features in my model are smaller than that number, which means it's going to erase them. And then your model will be wibbly wobbly, floppy wobble, wet noodle. It won't fly right. Actually, it'll probably fly right, but when the injection charge fires, it'll blow itself apart. Um, so make sure that is set to 0. Now, the other thing under filament settings, the other setting that you're going to be playing with, that's wrong. It should be 1.02. It keeps changing. I don't know why. But extrusion multiplier. Set this to 1.0. You're going to come back to this, and you're going to be changing this unless you get lucky on your first try. Change types of plastics, change printers. You have to mess with this. Now, inside the folder, one of the files is called test, right here. It's a little short segment that has the threads on both ends. Basically, it's a complete body seg, but short, so it doesn't take a whole lot to print it. So you're going to print the body seg. And after you print the body seg, eventually you're going to print 2 of them, okay? So this is a body seg. It has all the main features of the model. Launch lug, double wall body tube, male and female threads, okay? First thing you're going to do is you're going to give it a squeeze test. You're just going to give it a little squeeze. Make sure you don't hear too much crinkling and crunching. You might hear a little bit initially as some strings let go, but in general, as you squeeze this, nothing should give, okay? Now, if nothing gives, you're going to get a bit more destructive. Ultimately, you're going to print 3 of these, okay? One of these, you're going to see there's a whole bunch of ribs. You see that in the clear model on the screen. You're going to see that in the clear one. You see all the ribs? Those ribs are cuts in the model that almost touch the outside. And because we're over extruding a little bit, it accidentally touches the outside and the plastic fuses. If you don't extrude enough plastic, it doesn't fuse, and you'll end up with two separate layers and it won't work. One of these cuts, the one right next to the launch lug here, goes all the way through the model. The vase mode, you can't jump from position to position. It has to be one continuous extrusion. So I have to put a slice straight through the model so that the nozzle can move inside and outside without voiding vase mode. Because vase mode is where you get your speed and your strength in printing these parts. That's how I'm able to make such a lightweight part, yet make it so strong. It's a 6mm thick tube, and yet it weighs nothing. When you see how light these are, it'll blow your mind. So what you're going to do, I'm not going to do it to this one because I use this for demo. You're going to put your fingers on that slice, and you're going to crush this tube. You're going to destroy it and see how much force it takes to break that seam. I have one where I've been doing that. I have been beating the snot out of this. And I find that seam, and I crush it, and I twist it, and I rankle. Look at this. I'm tearing the model in half, and that seam has not broken yet. That's what you need to see. Your model is never going to have a puncture. It's going to be a crush like this, or from the inside. So the walls will hold. What you're worried about is that seam popping. You can't have that seam pop. If that seam pops, increase your extrusion multiplier 2%. So if you start at 1, go to 1.02. If that doesn't work, go to 1.04. Keep bumping it up until you're unable to easily break that seam. You can probably eventually break it, but you should mangle this part pretty decently before that seam breaks. When you get to that point, print 2 more of them. Make sure they thread together. Now, theoretically, the 2 launch lugs should line up, but I found out that's inconsistent. All I have to do is do this a few times, and the launch lugs stop lining up. The plastic wears and distends a little bit, and eventually the alignment doesn't work anymore. I have to figure out a modeling trick to stop that. I need a hard stop on the threads that doesn't result in them being loose, because these parts can't be loose. You want them snug, so there's no bending, there's no wobbling, and it should be relatively easy to thread these parts together. It's a 2-start, so it could end up over here. Just rotate it 180 degrees when you put it on. But eventually you should get to the point where you can do this to the part and not destroy it, and then the parts should still thread together. When you get to that point, print all the parts. You're ready to go. There's also a quick link in here. Actually, it's not in here, but it's in the files online. It's basically a little quick link. And this thing is strong. I have been unable to break one. I use this to rig my parachutes. So I'll have a piece of shock cord coming out of the rocket. It'll go to this. The shock cord coming from the parachute will go to this. The parachute will attach to the shock cord with one of these, which will allow me to dismantle my recovery system, put it back together, swap it, move it, change it around, because only 2 parts of this model need to be glued. Everything else threads together. That's going to be in the next video for assembly. This was just setting up a slicer and testing your prints using the test print until you get acceptable parts. This is important. This is a rocket. It is a missile without a guidance system and without a payload, but it's a rocket. This thing is going to go 300, 400, 500 miles an hour if you put a big enough motor in it. I mean, we've already flown this to over 1,000 feet, 5,000 feet, 10,000 feet, totally doable with a large enough motor. So respect this, all right? If you don't know what you're doing, print it for display and have a pretty rocket on your wall. If you want to fly it and you don't know how to, get help. Get with a club. Make sure, safety check. Make sure you test that part to destruction. Once you have that good, then you're good to go. You can build the rocket and fly it. This is a prototype. All right, this is not the gold standard files yet. This is the silver files. I still have somebody testing these for me. And if you want to test it, by all means, contact me. I'll work with you. I'll help you with adjusting print settings. You get me a couple pictures of the rocket flying, and you're good. All right, but be safe. All right, it is a rocket. This is a real flying machine. So this whole thing weighs about 1 pound. It's incredible that you can make a rocket that large, that light, and it only weighs 1 pound. You can see the ribs on the fins there. That's what gives them strength. But you know, I can twist and bend these fins, and they're not breaking. You know, it really is incredible just how strong this thing is. It's just, and yet this light. So make that test file, test it to destruction. Once you get your settings right, then print the rest of the parts and you're good to go. Everything threads together except for the motor mount. The motor mount is the only piece that needs any glue. Check your next video for that.